Okay, so in this video, we're going to go over some of those more complex derivation problems that involve nested subderivations. These were the ones recommended at the end of the 5.3 lesson video. Those were page 210, 2E, 2G, and 2I, I believe. So we're going to go over those. Some of these problems are more complicated than anything you'll see on the exam, but it's important that you get practice and experience with harder problems so that you'll be able to complete the easier problems, with some ease in the amount of time allotted. So that first problem was page 210, 2E, which was derive if A, then if B, then if C, then D. So this is three material conditionals all nested inside of each other. And we have that premise D, right? So that's going to be our consequent in that very last material conditional nested inside the consequent of two others. So the strategy here is to do conditional introduction, right? We're going to start with our first antecedent, right? And then we're going to start with A. We're going to try to get if B, then if C, then D inside that one, right? So that's what we're going for at the bottom of this subderivation is if B, then if C, then D. And now we need to start trying to get that, right? So we're going to do the same thing again. We're going to assume B, and now inside this subderivation, we need to get if C, then D. So how do we get if C, then D? We take the step one more time, one more subderivation, assume that antecedent, and now we need to get D, right? This is the easiest step. We have D as the premise on line 1. So we iterate D from line 1. And now we have what we're trying to prove, right? We have assumed C and proved D inside that subderivation. So we can go back one scope line and get if C, then D by conditional introduction from that most inside subderivation on lines 4 and 5, right? We assumed C, we got D. Now if you look at the next scope line out, right, we've assumed B on line 3. And then using that inside subderivation, we've proven the consequent we're trying to get, if C, then D. So we can go ahead and jump out another step. It's like Russian nesting dolls in this case. So now we have if B, then if C, then D. And if you look closely, that's on our scope line of the subderivation starting with A. So we've assumed what we want is the antecedent for the conclusion we're going for, and we've proven that consequent, right? If B, then if C, then D. So we can jump all the way back to our main scope line using conditional introduction again, and we've got A, then if B, then if C, then D. So this is just using those conditional introduction rules all nested inside of each other to create each of those material conditionals. We start at the first antecedent with our assumptions and work our way in. And then once we get that most inside consequent, right, in this case D, we start discharging those assumptions one at a time until we get back to that conclusion we were trying to get. The next problem was derive if A, then if D, then C. So we're going to take a similar strategy, right? We're going to assume A for conditional introduction. And then we're going to assume D also for conditional introduction, right? We're trying to get that consequent if D, then C. And the best way for us to do that is to assume that second antecedent inside that second subderivation. So now we've got to try to get C on the last line of this inwardmost subderivation, the second subderivation. So we've got to start working with what we have in the premises. We can get if B, then C from lines 1, where we have if A, then if B, then C, and line 3, where we have that antecedent A. So now we need to try to get B, which we can get using lines 2 and 4, right? Line 2 is if D, then B. line 4 is D, where we've assumed that as well. So now on line 5, we have if B then C, and on line 6, we have B. So on line 7, we can use conditional elimination one more time to get C. So now on that most inside subderivation, we assumed D and we proved C. So we can move back one scope line on line 8 and get if D then C using conditional introduction from that subderivation on lines 4 through 7. Now we're still in on a subderivation where we assumed A for conditional introduction, and then we proved if D then C, which is exactly what we were going for, right? A is what we want as an antecedent, and if D then C is what we want as the consequent. So on line 9, we can come out one more scope line back to that main scope line and use conditional introduction again, citing that whole subderivation from lines 3 through line 8. I'm going through these fairly quickly, and I think all of these problems use conditional introduction. Definitely pause and go back if any of this is unclear to you. The last problem here, we're trying to get if A then C. And from the premises, it's not the case that A or B, and if B then C. And we're going to take the same exact strategy. This is one of those strategies recommended in that strategies for derivations in Sentential Logic guide that is so helpful. It's got a list of, I think, 7 or 10 strategies of how to approach derivations, and this is one of them. If the conclusion you're going for is a material conditional, like we've had in all of these problems, then you can start by trying to assume that antecedent and proving that consequent. So we're going to do that again here. We're going to assume A as a premise for conditional introduction. And now we need to try to get C in here. Now we have no clear immediate way as how to get to C, right? We don't have B yet, but we do have it's not the case that A or B on line 1. So we're going to try using disjunction elimination, which remember is a subderivation rule that requires you to assume one of the disjuncts and then prove what you're trying to get. In this case, we'll try to prove C, and then a separate subderivation, you assume that other disjunct. So we're going to start by assuming it's not the case that A, as I said, for disjunct elimination. And here we see a clear strategy for getting C, right? We don't have a clear way to get, we can't get to it directly, but we have A on line 3, and it's not the case that A on line 4. So we have a contradiction we can use. So I'm going to assume it's not the case that C as a premise for negation elimination. So we can use that contradiction to get C back out, right? So we're just going to reiterate A from line 3. Remember, you're always allowed to reiterate rightward across scope lines as long as you're still inside those subderivations. And then we're going to reiterate not A from line 4. Now we've assumed the opposite, and we've gotten a contradiction in that subderivation. So on line 8, we can discharge that premise and move back one scope line, and we've proven C from it's not the case that A on line 8. So now we need to assume the other disjunct from line 1, right? We need to assume B, and we've got to independently prove C from this one as well. We can't use anything from lines 4 through 8, but we can use everything on lines 1, 2, and 3. So I'm going to reiterate from line 2, which is if B then C. And now we can pretty straightforwardly use conditional elimination. We have B, and then we have if B then C. We have the whole conditional and the antecedent. So we can get C on line 11, again, using that conditional elimination. So now remember, we did these two subderivations for disjunct elimination. We assumed the first of the, assumed the first disjunct and proved C follows from it. Then we assumed the second disjunct and proved C follows from it as well. So on line 12, we can move back one scope line and write down C using disjunction elimination, which remember you have to cite three things. You have to cite the original disjunction, which is line 1. You have to cite where you prove the sentence you're taking out, the sentence you're discharging from the first disjunct, which in our case is 4 through 8, and then where you independently assume the second disjunct and prove that same sentence, which is lines 9 through 11. So now we're back on our second scope line. We remember assumed A on line 3 as a premise for conditional introduction. And then all the way down here on line 12, against that same scope line, which is really important. You have to be on the same scope line to use any of these rules. We've proven C. So we can end our subderivation on line 13 by discharging that subderivation and write down if A, then C. And in this case, this is conditional introduction from lines 3 through 12. Now, again, I went over these problems fairly quickly. The idea was that you've worked on them yourself, and then it came to just kind of check your work or see a different way of doing it. Again, you can pause, rewind, go back if any of that was a little quick. And of course, you're welcome to bring questions to class or to office hours, or even just send me an email, and we can make an appointment if office hours don't work for you.